Good morning all. I am Pradosh Kumar, Assistant Professor from the Department of Biomedical Engineering. Now I am going to present a topic on Operation Amplifiers, characteristics and inverting amplifier configurations. First we have to know what is an operational amplifier. An operational amplifier is a direct coupled high gain amplifier. It consists of one or more differential amplifiers followed by a level translator and an output stage. Operational amplifier is a versatile device that can be used to amplify AC as well as DC input signals. It is designed for computing mathematical functions such as addition, subtraction, multiplication, integration, and differentiation. This is a symbol of an operational amplifier. The second pin is in inverting input. Third one is a non-inverting input. And we have fourth and seventh, which is a dual power supply. Sixth, the output will be taken from the sixth pin. First and fifth is not used. It is used for null offset, so that output will not have any value when we are not giving the input. And eighth pin is a no connection pin. So out of this 8 pins, we are using the 7 pins functionally. That's why we are calling this op amp as a 741 op amp, because 7 pins are functionally used, and we are giving 4 inputs to this, that is second and third pin, and fourth and seventh pin are considered to be input for this op amp, and it is called 741, or the last one we are saying for, because the output is taken from the sixth pin. That's why it is called a 741 operational amplifier. Next, the ideal characteristics of operational amplifier. Infinite open loop gain. The gain should be infinite. Second is zero output impedance. The output impedance of an ideal op amp should be 0. Next is infinite bandwidth. The bandwidth should be infinite. Next one is zero offset. That is, when we are not giving any input, there should not be any output. If there is output, then we have to nullify that. Next point is infinite CMRR. So the next fifth point is infinite CMR. CMR is common mode rejection ratio. The output will be the infinite of the CMRR. So the sixth point is infinite slew rate. That is, the slew rate should be infinite. What is the slew rate means? It is the rate of change of output voltage with respect to time. That value should be infinite for an ideal op amp. So this is a diagram of an inverting op amp, where the input will be given to the inverting stage. That's why it is called the inverting amplifier. Also, the output we will be getting from this amplifier will be a 180-degree phase shift. That's why it is called an inverting amplifier. The output voltage will be minus Vin into Rf by R1, where Rf is the feedback resistance and R1 is the input resistance, and Vn is the input voltage. So output voltage will be the multiplication of voltage input multiplied by gain, where the gain is nothing but here minus Rf by R1. So this is the derivation of an inverting amplifier. So first, how we have to find the I1 and IF. For that we need to use Kirchhoff's current law. So as per Kirchhoff's current law, first we are going to find the input current R1. So the value of the current flowing through input side, input resistance, is input voltage minus this VB. VB is the value, voltage value will be 0. Why it is 0 means the non-inverting terminal is connected to ground. This concept is called as virtual ground. When non-inverting is connected to ground, at this point of inverting input, we will be getting the same value as a voltage. So this is 0. So our current will be potential difference by resistance, where potential difference Vin minus Vb by R1, where the value of Vb is 0 since it is virtual ground. So the next one is feedback current through resistor RF, that is feedback current IF equal to potential difference, that is 0 VB minus V out V0 by feedback resistor RF, where VB is 0. We already explained how VB is 0 due to virtual ground concept. So VB is 0, so we will be getting minus V out by RF as the equation for IF. Next, we know that input bias current is 0 here. So input I1 is equal to feedback current IF. So equating that, we need to equate the right hand side of this two. So substituting the equation I1 equal to IF, the right hand side is Vn by R1 equal to minus V out by RF. So we may, from this equation we need to find output voltage as minus RF by R1 into voltage input. So we know that gain is nothing but minus RF by R1. Voltage output equal to gain into voltage input. So the gain we are getting here is minus RF by R1. So from this we have found how to find the gain of an inverting amplifier. This is called the inverting amplifier. As we said that the output will be the inverting of the input. So this negative sign indicates a phase inversion. So this is the waveform of the input and output of inverting amplifier. Suppose we are giving the sine wave as the input, then the output voltage will be the phase shift of 180 degrees. So it is an exact inverse of the input. Also we will be the value of this voltage will be amplified based on the gain. Here we have taken the gain as, assuming the gain as 2. So the output, if it is if the input given is 1 volt, then the output will be multiplication of this input into gain. So the gain we have taken as 2. So gain 2 means input is given in this case as 1 volt. So 1 into 2 we will be getting the output as 2. So that's why we have got the output for the inverting for the positive half cycle inversion happen, and also the value as per gain to multiplication of the input 1 into we input voltage is 1 into 2, so we have got the inverted value minus 2, and for the negative half cycle the value have got inverted, and also the gain factor is 2, so we are getting the negative half cycle also as the inverting with 2 amplification factor of 2. In this way we are getting the inverting amplifier. And also for this inverting amplifier we can able to get the design of the inverting amplifier in a way where suppose if you will be knowing the output voltage and we know the input voltage, so we can able to find the value that need to be set for the feedback resistance and input resistance. Suppose if the output, consider we are assuming the output voltage we need as 10 volt. So if the input voltage is 1 volt means, then what happened, we need to get the 10 as the output. We know the input is 1, so what should be the gain? The gain should be 10, then only we will get the output voltage as 10. So that also again the thing is it should be inverted value. So since minus is there, we will be getting the minus 10 volt as the output. If output voltage, if input voltage we are giving is 1 and we need the output as minus 10, then if you are using this value accordingly as the design to get the output voltage of 10, so we can consider the value of the resistor can be assumed as, suppose the value of feedback resistor is 10k, and if you assign the value of input resistor as 1k, then we will be getting the ratio as 10. So in this way we can able to get the value of output voltage as the amplification and also the inverting of the input. So that's it about this inverting amplifier. Thank you for listening to the session. Thank you.